Any language which supports these object-oriented concepts, encapsulation, inheritance, polymorphism, abstraction and modularity, called as object-oriented programming language. In the introduction class, we have already seen while we are designing very complex software system, it would be very difficult to design it with the procedural programming languages because of that flat structure. Data can be accessed by any of the functions, so it would be very difficult to maintain the data integrity, and also there is no scope for modularity and hierarchy. Today let us see this first object-oriented concept, encapsulation. In procedural languages like C, data does not have owner. This leads to the problem of difficulty in maintaining the data integrity. Let's see this small code. Int t equal to 85 and this print statement. Here t is the data which is publicly accessible by the code around it. Means any function can read it and can also modify it. This is the shared data, can be accessed by these three functions, function 1, function 2 and function 3. If something goes wrong with the data, it would be very difficult to identify which function has misbehaved to create the bug. Encapsulation is a language mechanism for restricting direct access to objects' data members. The process of binding of the data with the methods that operate on the data is called as encapsulation. It mainly provides the security to the data. This is the visual representation of encapsulation. This process of binding instance variables and its related methods in single unit class is called as encapsulation. In Java, we usually keep instance variables and methods in single unit called class. Then each data will have proper owner. If some data corrupted in some class, we can identify bug easily by checking methods of that class. In our previous videos, so far we have seen two classes, person and student. We have been committing one of the most serious mistakes in object-oriented programming. What is that mistake? We are exposing our data. In this person class, this is our data, person name, age and gender. When we say exposed, we mean that the data can be accessed and modified directly by using dot operator. Means from this person demo class, I am directly able to access this person class data. Let me reset the value for person 1. After resetting this age for person 1, if we print the details, now this age is updated here. Imagine someone using this capability to directly change the person 1 object's age to an acceptable value. For example, something person 1.age equal to -10. Let me run this. This new statement reset the value to -10. Person age could not be -10. In the hands of wrong person, a reference variable is a dangerous weapon. Even we have owner for this data, age, here owner is this person class, still this age is misused. Means it should not have negative value, means this data is exposed. Then what is the solution? We need to hide the data. How can we hide the data? Here for this data we did not mention public or private. We have already seen public access modifier, means this main method can be accessed from anywhere. In Java we have other access specifiers also, private, public, default and protected. The members which are declared with public access modifier can access from anywhere. The members which are declared with a private can be accessed from within that class only. If we do not specify any access specifier, private, public, protected, then Java will treat those variables as default variables, means will assign the default access modifier. Those members can be act like private variables within the package, and protected members can be accessed from the subclass only. We can hide the data with the private access modifier. For simple understanding, let me change this code. Now also all these members can be accessed from other class. Let me run this. Now this person 1 age is set to -10, means this data is exposed to other classes. To hide this data, mark your instance variables with private access modifier. If we run this program after changing this access modifiers to private, now this age cannot be directly accessed from this person demo. This is another class. So to hide the data, by making all these instance variable private, we are hiding this data from other classes. This private data can be accessed through only public methods. Usually, programmers provide public setters and getters to access the data in controlled way. Let me add one more variable. If height greater than 0 centimeters and height less than 230 centimeters, then this instance variable height will be set with that local variable height. This is validation. By the setter methods, we can ensure that no wrong data can be set to this height. Means height should be greater than 0 and less than this value. This is the controlled access. Write this getter method. To access this private variable height, other classes like this person demo can use these two public methods, set height and get height. We can validate those data by using this setter method. This is the controlled way of accessing private data. Writing this kind of getter methods also not good idea. Here anyone can retrieve height from the object. Since now age is private variable, this age is not accessed from here, so let me remove these statements. Person height is also private variable, but we provided the getter method, so we can access it here to public method. Here we are getting 0. Let us set by using setter method here. Suppose if I try to set the value to minus 20, it will not be set since we are validating height should be greater than 0 and less than 230. So we need to set proper data. Let's say 165 centimeters. Now this 165 is set to this height. We are getting that height here. This is also not good idea. Here anyone can retrieve height from the object and make assumptions about data, like some programmers might assume this retrieved height might be in centimeters. Some other programmers might assume that retrieved height might be in inches. Even if they assumed correctly, let's assume height is in centimeters. After some time, if we change that height from this centimeters to inches, then others need to change their code. Means they might be doing some calculations with this height, which was previously in the centimeters. Now it is changed to inches, so they need to change the code. Providing getters is also not proper encapsulation. The only way to encapsulate variables is to make sure nobody can touch it either directly or by retrieving it from the object. Then how can we achieve that? Here this getter method is also exposing the data. Just we need to stop exposing data and start exposing functionality. For example, add method like this. Now we change the getter method like this. Now we need to change this getter method, all this public method to string height. Its return type is string. Let us run it again. Now this code don't allow anyone to retrieve height anymore. If and when we decided to change the height to inches from the centimeters, we'll make the changes just once in this class here. Inches. Here also we'll modify this validation according to inches. Then there would be no chance of different assumptions like centimeters, inches and meters. So instead of using getters, just use these print methods. By making all these instance variable private and encapsulating all of them within this class, we are ensuring that that data cannot be accessed from outside. So we are providing security for these instance variables. Let us see the summary. Encapsulation is the process of grouping the data with its related methods into a single unit called class. It is mainly used to prevent the unauthorized access to the data members of the object. These are the advantages of encapsulation. Encapsulation provides the security to the data. Other classes cannot modify data, so there is no scope for misuse of data. So data integrity will be achieved without affecting the other code. We can change in our code, means we have code flexibility without bothering about who else are using this data. And encapsulation also provides the modularity with the use of classes. Encapsulation increases the maintainability. Due to clear organization of code, it would be easier to fix issues as each class responsible for specific functionality.